All right, for all those people that just showed up, the notes are sitting over there and trying to host it. So let's see. So class.
Yes.
All right. Thank you guys, gals, people, creatures. You are. I'm glad you're here. Okay. So implicit differentiation. So again, this is actually it's creative. It is thought provoking. It is different. So if you think it's hard, yeah. It is complicated. There's more than one variable. All these times we've been actually finding the derivative. We actually have y prime, or in Leibniz notation, dy dx. We would be finding that, but now we're going to actually find it with two variables at the same time. So we're going to be using implicit differentiation to find dy dx, or dx d whatever my variable is. So different things that we're actually doing from that. Okay, use implicit differentiation. So this is my original problem, and if you look at the notation that I have here, this is set equal to 0. That's important. So we have equations like this where we have an equal sign, where we have implicit differentiation. Okay, that's a good start right here. So find this if I'm looking for that. Now, I have an x and a y. So I have an x and a y, right? So what that means is I need to actually find those together, because it's not just y equals, it's finding those together. So I'm going to go to a new page. So xy minus 4 equals 0. Now, what's happening in between that x and the y? Multiplication. So if it's multiplication, what else does that tell me? Do I have a rule? What rule? Product rule. Thank you. That's what you're trying to say, right? Product rule. So again, I'm going to call this one F. I'm going to call this one G. So F prime is it's just one, right? Okay, just one. Okay, and G prime is 1, but I'm taking the derivative of something that is not x. What's wrong? Yeah. No, it's not. No, it is 1, but since I'm taking the derivative of something that's not x, I need to say that I'm taking the derivative of something that's not x. So I'm going to add a dy dx. So it's 1 dy dx. Because it's telling that I'm taking the derivative of y in terms of x. This first one, the f prime, is just, I took a derivative of x in terms of x. So I don't actually need that. Does that make sense, or do you want me to write that so you see it? Okay, so it's a dx dx, because I'm taking the derivative of x in terms of x. That's what that reads as.
How do you take the derivative of y in terms of x?
Right here. What's the derivative of y? Because if y is my variable, then the coefficient, the number in front of it, is going to be 1, right? Okay, and then do the rule. Subtract 1 to my exponent, so I just get y to the 0, which anything to the 0 power is 1. There we go. So I just get 1. But now, since I am over here and I'm taking the derivative of something that's not x, I need to add this to state that I'm taking the derivative of something that's not x. Does that make sense now? Okay. All right, so I'm going to keep going. So this is the reason why derivative of x in terms of x, that's why this does not matter. Okay, so right there we get there. So we're using product rule now. So f prime is going to be 1 times g, which is y, plus g prime, which is 1 dy dx times f, which is x. Now, derivative of minus 4? 0, right? So that's 0, and then I'm going to equals 0. Derivative of 0 is 0, right? All right, that was the crazy part. Question so far? No questions yet? Okay, I'll continue. So now I'm going to clean this up a little bit. So now I'm going to have 1 times y is y, plus 1 times x is x, dy dx. Now, I need to get, since I'm trying to do this in Leibniz notation, I need to get the dy dx by itself. So this is actually a multiplication that's happening there, right? So I need to use my algebra rules. So if I'm trying to isolate the dy dx, I need to start by subtracting y to both sides, right? Minus y. So now I get x dy dx is equal to negative y. And what? Divided by x. Very good. So I get dy dx is equal to negative y over x. So this is how we do this when we have more than one variable. So I eventually solve for one of my rates of change, my dy dx here. So I get this. So I would actually have to find the x and the y coordinate if I wanted to find the slope given this problem here. So these ones, you don't just plug in the y, or I'm sorry, don't plug in the x to get the slope of the line. We have to plug in the x and the y to get the slope of the line.
How can something move in two directions at once?
They like to move it, move it. They like to. So everything that we've been doing up until this point, let's think of the physics. Positive velocity goes which way?
Right?
Negative velocity goes. What do you think it's going to look like if I'm actually doing in two directions?
So you just stay
So
still.
I'm going in this direction here, and I'm also going in that direction there.
But isn't that just what slope is already?
This is for the equation. We will find a slope, but the equation of this. So even better, I'll show you by graphing this, and I think that might actually help this. Because we're going to have a...
Like, what is the purpose of solving for both variables at once?
I'll show you. So now, I know you guys are following along here. So I'm going to show you how to do these type equations right now. So if you're not taking notes, then you'll probably screw this one up. So I have right here where it says f of x. I'm going to back this one up, hit delete, and change it to a relation. So my relation is going to be x times y plus, or is that minus 4? Was it plus or minus 4? Minus 4? Okay. Minus 4 equals 0. All right, there we go. So we have equations that are not just regular linear or the quadratic and all those other ones that we've had. Now, what we're going to do is we're going to have the graph. So I'm going to menu, analyze graph, derivative. Let's say, so when I plug in something, I have to plug in at a certain point. Let's say 1, negative 4. So that one right there. So I get a coordinate on that one right there. So it's going to give me a slope of negative 4 at that point. So I'd also have to look at, so my x and my y at the same time. Before, we actually had an equation. We plug in our x, we get our y, right? From my original equation, y equals mx plus b. I plug in whatever x it was asking for, and I go from there. Now, I have 1. I have to also find the y to go along with that. So it's going to be the other variable that I have here. So that's 2, 3, 4. And I get a slope of negative 4. So let's go back to my problem. It was, my coordinate was 1, comma 4. I plug that in. I get negative 4 over 1. So that gives me my slope.
I should take a relation again.
Huh?
I should take a relation.
Yeah, relation. So yeah, you have to go backspace when it's on f of x, hit delete, and it will bring up the options for relation.
What? What's the point though?
The point is 1, 4.
But like,
See what I did there?
in what ways is
We,
helpful?
you'll see when we apply it here in a moment. Okay.
Okay.
Hopefully that'll help. So do you understand the math in the first place?
Yeah.
We will apply it. So if you really want to know, you can look at that crazy guy in the back of the room. He's actually doing that with multiple. Tree, is that the one that actually has like a, you have like a dr dt and a dx dt? Is that one? With the, nope, you have a theta, right? So he's changing a theta as it's also changing a, what else are you changing on that one? The x?
That height is constant. Position of x direction.
Yeah, that's why. So, did you just get distracted by something shiny? Squirrel. No, yeah, no, seriously. Tree was just circling that, what he's doing, and that's at some point where you're going to be at.
Okay.
So, yeah, you. Yeah, is that the second problem or still the first problem? Is that?
This one is the second problem. This one's the third one.
Okay. So, yes, there is a lot more drawing and a lot more steps, like progress. Right now, we're just trying to get to the first thing. So, thank you, Tree. Implicit differentiation, solve for y, and then differentiate. We did this. Verify the results, A and B are the same. Now, we said that dy dx is equal to negative y over x. right? The second one that says solve for y instead. So going back to what you were trying to say, like, why would I have to do this? Yeah, we're going to do it over there. But at this current moment in time, we're starting with a simple problem that you could do either. So x times y minus 4 equals 0. So if I'm going to solve for y, I would start by adding 4 to both sides, right? Okay. So x times y equals 4. And then from right here, divide by x. So I get y equals 4 over x. But before I take my derivative, I'm going to say that y is equal to 4 times x to negative 1, right? All right, so what do we do now? Take the derivative. So I get my y prime is equal to negative 4x to negative 2. So y prime is equal to negative 4 over x squared. Now, didn't we already use a coordinate? What was that coordinate that I chose? 1 comma 4, right? So coordinate at 1 comma 4 over here, as I plug that in, I got a slope of negative 4 over 1, right? Okay. Now can I do it again over here? So I don't need the y value, I only need the x value here. So that's going to be negative 4 over 1 squared, which is still negative 4 over 1. Does it give me the same thing? Yes, it does. Is that correct, Ray? Yeah.
If you try to solve for x, will it give you the same, that you can just plug in the y value to find the derivative?
You should. That guy. I almost heard you say something.
What's the integral?
Integral. Integral is the opposite of the derivative. So, if you would have a multiplication, how would you undo a multiplication? Division. Everything in math has its opposite which will undo it. So a derivative has its opposite, which is integration. So to undo a derivative, I do integration. To undo integration, I do a derivative.
I thought the opposite derivative was antiderivative.
Antiderivative means the same thing as integration. So, all right. Let's see where we are. Right. Heart. Okay. Power rule for functions. Same thing. Where n is an integer, f of x takes the form. Now, okay, if you notice, this is the notation for this, and you'll see here in a moment. Convenient notation uses implicit differentiation when y to the n appears. So, because we're not using the tick marks for these, we're using the dy dx. Because the tick mark could easily be mistaken, especially when you're going back over your work for a first power, isn't it? Yeah, it's fine. can throw it up on that other one. So these should be in your notes here. This is important. So this is the way that we write it. So when we're plugging these in, we don't say that it's going to be f prime of that number or y prime of that number. It is dy dx such that right here, x comma y. So that's the coordinate that I'm going to be plugging in. Yes.
Is that x 0, comma y 0?
Yeah, it's the point that we have. So it's normally referred to as sub naught. That is my original or my point that I'm actually using, my coordinate.
Can I just check the origin?
So it's saying the derivative at that point.
Yeah, derivative at that point, or it's whatever point's given you. So let's say we were using a growth or decay model, okay, and you're in chemistry, you're doing, or one of those problems that you actually have those, x sub naught refers to my initial. And so in our math, our initial would be this one right here. So x 0, y 0. So that's the point that's given. Yes? Okay. All right. So find dy dx. This is what it's always going to look like. Something crazy like this. X squared, y squared. What does that mean? What is that going to give me if I have an x squared plus y squared? What is it? That's a C. The C. Okay. It's a circle. So if you try to graph x squared plus y squared equals whatever value, that is the circle. That's the equation of a circle. The r in the end would be the radius of that circle. So we're going to have some type of circle. Can I normally graph a circle? Say no. Why can we not graph a circle? It's not a function. What rule does it violate of it being a function? Vertical line test. Vertical line test. So it fails that because for a function to be a function, it would actually have to have one x for every y. One y for every x. There we go. One y for every x. But in a circle, you have a one x coordinate. But if you're looking at the circle, we should cross and we should have a y value up above and a y value down below. If we're thinking about a basic circle, right? So we'd actually have on 2. So 1x would actually have 2y. So that would mean it's not a function. I can't graph it normally. That's the reason why I put it in relation to graph that into my calculator. So we can still graph this. Now, I'm going to go ahead and do the derivative of each of these. So the derivative of 3x squared is going to give me 6x. Very good, right? Now, this next one's going to be, now take the derivative of 4y squared. ay dy dx. Because I am taking the derivative of something that is not x. So I state that it's derivative of something that's not x. Equals. What is it? 2. Very good. And my whole goal here is to get what by itself? dy dx, right? Get the dy dx by itself. So we got to do a little bit of move it, right? Subtract 6x both sides. So 8y dy dx is equal to 2 minus 6x. And again, what is happening between the 8y and the dy dx? It's multiplying, right? So to undo that multiplication, I need to divide both sides by 8y. So I now have dy dx is equal to 2 minus 6x over 8y.
Will we be able to do 3.2 just based off of this day?
No, like some of the stuff you're probably going to end up having to look at some of the other videos too. So hopefully you guys find my videos and they're not too annoying. And if they are kind of annoying, go back a couple years. They're like, oh, okay, I understand it that way. So every once in a while, you might actually find something pretty funny. So I had someone going, I don't know if it was last year or the year before. They were just randomly going through all my trig videos they're watching, and because they were trying to refresh trigonometry, and I uploaded a video. Apparently, some guy died, some like famous guy, and I was like asking a math question to this person, and they were staring at their phone. They're like, "Oh, so and so just died." And some, I don't know, rapper that OD'd or something. Anyway, and I was like, "Yeah, he's still dead, you know, but can you do the math problem?" Yeah, and so they found it hilarious. Anyway, but still. All right, questions, concerns, complaints, conspiracy theories over what I did here? Not yet? So we have about 15 minutes of class left. I want you to use this time to start some of the problems that we're doing right now. So make sure, again, like, share, and subscribe.